Happy Monday, boys and girls. Hope you've had an excellent weekend, and I hope you're ready for another fat week of nothing but progress. That's our motto here. So, before I flip this whiteboard, okay, before I flip that bad boy, have a looky at this, all right? Have a looky at what we got here. So, over the weekend, I've been hard at work getting the serialization versioning system working, and well, hey, let's go ahead and compile this. Right now, go on to res, we don't have a world. We don't have a map at all. We are on version 0 of the entity struct, okay? We're coming in strong. We're starting to create the world. We booted up. We placed in some ground segments. You know how it goes. Commit that bad boy. Write map data. It's there. It's beautiful. We come along and we decide, you know what? It's time to add in a new value. Age for some reason. I don't fucking know, but it's there. We do some stuff with that, and then later on, it's time for version 2. Let's go add in yeet. Oh, lovely. So this is the latest version, but this is the version the world is currently on at the moment. Version 0. How on earth is it gonna deserialize that, I wonder? I wonder, boysies. When I hit run, is the world map gonna be read back in properly? Huh? With all this new data, I wonder what's gonna happen. I wonder. Cast your votes. Will it crash? Will it shit the bed? Or have I done a good job? Attention. What will happen? It's there! Serialization versioning is complete. It has read in the old version of the entity and converted it to the new one. It is now in the latest version 2. If we go ahead and commit this back, recompile, rebuild, and even if we get rid of all this old shit and we say that this is now version 0, recompile, reload, it's gonna work. Or not. Oh god. Oh fuck. Oh shit. It's gone. Where'd it go? Where'd the entities go? Eggment. The fuck is an eggment? I wonder. Okay. If we go into the catch-all over here and we look at the function that serializes this, right? Entity version 0 to file. It comes in. It's beautiful. About write entity to file. Write entity to file. Okay. It writes the version. It reads the version. On disk, the version is number 2, but it's saying it's number 0. Okay. Now if we go into remedy and hit this breakpoint, I wonder, what is the actual version gonna be? This one. Right here. Right here. Right here. What is the actual version? The actual version is saying it's 0. It's gonna go through. It's gonna do all this stuff. But for some reason, Eggment. Why? Who is Eggment and why is he here? That sounds like a problem for future Randy. We're gonna go ahead and pretend that that worked completely fine and move on with our day. Wow, isn't that amazing, boys and girls? Oh my god. Code not working? Nah. Do I know you? Have we met? So let's go ahead and get started with today's work. I wonder what that's gonna be. I wonder. It's a mystery. What are we going to be working on next? The next task on the list is getting the rendering done for the ground system all sorted. Once this bad boy's in, we're going to have a fully functioning ground system, and then from there, we can go work on new things. Now, there's 2 ways we can go about this rendering, okay? 2 ways right here. Way number 1, we can do something similar to the pixel simulation devlog, right? Where we just create like a big buffer. Just say, buffer. That is excellent handwriting. Buffer of pixels. Okay, we just come in like, hey, this is what the ground looks like, and we are gonna generate out a big fuck off array of just pixels and shit, right? And then just fill it in. Now that's obviously gonna be fixed. You're not gonna be able to change it. It just gets passed in when the world is created. It goes, let's create this big thing. Cool, Dunskies. But it's not exactly the best thing in the world, right? Not exactly cash money because it's not dynamic. We do it once and we're done. We're gonna have to regenerate it if we change the height of the ground and so on and so forth. But it would be pretty efficient, right? Once we've done it, we don't have to go back and redo it. So it would save some power with that. But it's a little bit boring, okay? A little bit boring. We could have some fun, okay? We could render it on the fly with shaders. So we come in and we take a bunch of ground positions boop, beep, boop, 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 and render them on the GPU on the fly. This is going to be a lot more flexible at the cost of it being a little bit more performance intensive. I'm sure we can make it work. It's going to be fun. It's going to be beautiful. I have no goddamn idea how shaders work. That's what we're going to be doing today. We're gonna be getting shaders working and figured out and sorted. Got quite the task ahead of us. How the hell am I gonna get that into a shader? And where are shaders even stored to begin with? Generated shaders.c is empty, okay? Okay. Gotta be here somewhere. Gotta be here somewhere. Renderer? TS2D. Oh, here we go. Here we go. Really, my only goal for today is just figuring out how I can actually start doing my own shader code. What we need to find out is where is the shader code? GL_vertex shader. So these are just char pointers. So let's figure out where that function gets used. TS2D init open GL shader from data. Right here. All right. So this is where the load shaders happens. Cool. Okay. So it's looping through a bunch of shaders. So this is Datadesk. So this is where all the shaders are. Ryan's got some Datadesk code and Telescope that is generating the shaders. I do not have access to that. Thanks for coming, boys. It's been an excellent stream. I guess I will see you tomorrow. We got so much work done today. Adios. Is what a little bitch would say. Just because we've encountered one tiny, minor, little obstacle doesn't mean we ain't got more shit that can be done. Now, yes, I can't touch the shaders. There's still some more things we can do to prep for the shaders. Coming in too. All right, you see right now, all right, how we come in the world. Well, goodbye. And these bad boys right here, they're each different entities. That's obviously not the most cash money thing to do because like, how are we going to go through and pass this data to the shader efficiently? I mean, you know, sure, we could loop through all of them and then just like create some big like array of vertices and chuck them in. I think it's going to be better to literally just take all these and merge them into one entity. So we'll have in each chunk, we'll have one entity, which is just the ground. And it's just going to be a big vertex array of all the different points in the ground. So that's the first thing we're going to be doing. Literally, all we've got to do is go into the entity presets, and we're just going to have to start treating this entity differently, okay? So instead of it being a line, and we've got P1 and P2, I'm guessing we make it a big polygon. Yeah, that's going to be very fucky for the collision system. We could create a new shape, which is just like round, and it's just going to be like the way it gets treated in the collision editor. It's just a bunch of small little lines. It just divides up then. We could just call it like a ground segment, honestly. Ground segment. If we compile that, that should be all Gucci in the hoochie. Yes, it is. And then when we come into the ground segment, we're creating one initially. What's the size of the chunks again? Chunk size is 256. Divided by 16 is 16. Who would have thought? Instead of it being a line segment, and it's going to loop, create like 16 different vertices. Line seg dot count is equal to 16. Line seg dot vertices at I equal to v2 I times it by 16. Take away 128. Now it's not going to collide properly. First of all, let's just get it rendering. So let's see if it's rendering now. I don't know. Shit the bed, of course. Oh, it's just trying to collide. It doesn't know how to handle the collision, which makes sense. Look at that. It's there. It works right off the bat. That is so cool. Right there should just be a line segment of 16 different things. So initializing it to that, then we are overriding what the actual meaning of it is. So that should now be a bit better. Now it should actually have some proper physics data to work with. What is this? Like it kind of works? It's not really that well. I really don't want to debug this collision because I suck balls at doing it now because I have not touched it in months. There's no way I'll be able to figure out what's going on here. So either I figure out what's happening in the next 5 minutes or I completely scrap this idea and go back to what I was doing before. It's like sinking down. It just wants to go down. That's just not right. All right, maybe it's in the collision code actually. So what's happening here is it's going through, it's applying all this shit. The values aren't being updated properly. There's a reason they're pointers and not copied data over is because it needs the newly integrated positions, the newly applied impulses, all that sort of stuff, new velocity, right? Like you can't just move the position, no? You fucking know what, mate? Hold down Control Z like the madman that you are. I'd be undoing all this shit. Woo, yeah, goodbye. What else are you gonna do? Okay, so if the collision distance manifold depth at 0 is depth 0 or the depth at 0 is less than. If this collision distance is less than that, then we're gonna go ahead and update the bad boy. That right there should actually just be the entire fucking thing done. I don't know if it's gonna work. All right, the moment of truth, what we've all been waiting for. Is the code going to work? Is the line segment going to not shit the bed? No! Back to the drawing board. Oh, it's this right here. Oh, you dumb little fuck. How dare you? It's working! Woo! Let's go! So look at that. Hell yeah. Sexy. that right there is the ground editor all sorted. When it comes time to put those bad boys in the shader, we can literally just put 16 of them in at a time and it'll be sexy. Adios. Take care.